We're now ready to discuss exponential functions. First, let's provide a definition. An exponential function is a function of the form f of x equals a to the x power, where a is a positive real number and a does not equal 1. The domain of f is the set of all real numbers. Why does a need to be positive? A needs to be positive so that we can have a domain of all real numbers. For example, suppose that a was -2. Could we then evaluate f of 1/2? No, because f of 1/2 would equal -2 to the 1/2 power, which is the square root of -2. That wouldn't give me a real valued output. Why doesn't a equal 1? Because then I would get f of x equals 1 to the x power, which is sort of a boring function. 1 to the x power would just be 1. So let's look at the graph of a specific exponential function, f of x equals 2 to the x power. The way we're going to obtain this graph is we're going to use our point plotting method. I'm going to pick values of x, and then we're going to evaluate the function at those different values of x. So let's start with small values of x, say -10. Then the value of the function would be 2 to the -10 power. 2 to the -10 power is 1 over 2 to the +10 power, which is about 0.00098. So it's rather tiny. What if x is -3? Well, then I would get as output 2 to the -3rd power, which is 1 over 2 cubed, or 1/8. What if x is -2? Then I get 2 to the -2nd power, or 1/4. -1, I get 2 to the -1st power, or 1/2. If x is 0, I get 2 to the 0 power, which is 1. If x is 1, I get 2. X is 2, I get 4. If x is 3, I get 8. If x is 10, I get 2 to the 10th power. 2 to the 10th power is 1,024. What I'm going to do is take a few of these points and plot them so that we can get our graph of our exponential function. So I'm going to start by graphing the point -3, 1/8, which is right around there, -2, 1/4, which is a little bit higher, -1, 1/2, 0, 1, 1, 2, 2, and then 2, 4, 3, 8, which is already off on my board here. So now what I'm going to do is connect the points into a smooth curve, and I get something that looks like this. So there's the graph of the exponential function y equals 2 to the x power. What are some of the things that we should notice about the graph of this function? Well, we should notice first that its domain, again, is all real numbers. What about the range? Well, clearly, x can never equal 0 because 2 to the x equals 0 does not have a real solution. So the range is all positive real numbers. That is, the range is the interval 0 to infinity. What else can we figure out? Because I never crossed the x-axis, I have no x-intercepts, but the y-intercept, we should notice, is 1. When x is 0, y is 1. What happens to the graph of the function as x goes to -infinity? As x goes to -infinity, the value of the function gets closer and closer to 0, so we say y equals 0 is a horizontal asymptote as x approaches -infinity. What else can we figure out? Well, as x gets bigger and bigger, the graph gets larger and larger, which means that the function is an increasing function. Because the function is an increasing function, it's also 1-to-1, and because it's 1-to-1, it will have an inverse function. Stay tuned for a definition of the inverse of an exponential function.